All right, welcome back. Happy Wednesday. We're going to move right along and do lesson 70 today. We will be using our little blue books to add some more formulas in there. So if you don't have that, you can go ahead and find it. We're going to write a few definitions and then we'll be putting some stuff in there. But today we're going to talk about the surface areas and volume of pyramids. So they say surface areas because they were really talking about the lateral area and the surface area in those. They put both of them in the same. But the first thing we need to remember about pyramids. What do we know about a pyramid? There's a great picture in your book. I'm going to pretend I draw it, but I'm not really going to draw it, okay? We need to talk about the vertex of a pyramid. Is the common vertex of the pyramid's lateral faces. Common vertex or point is the very point on the top, right? And you remember lateral simply means sides, okay? The vertex of the pyramid is the thing at the very tip top. Okay. The base of a pyramid. The thing it sits on, right? Yeah, it's the face of the pyramid that's opposite the vertex. Okay, and there's just one base of a pyramid. There's only one. Okay. If you have a regular pyramid, it's a pyramid with a regular polygon as a base and lateral faces that are congruent isosceles triangles. Sorry. So you've got a regular polygon as a base. And all the lateral faces are congruent isosceles triangles. Okay. All right, last one. I'm going to scroll just a little bit because I'm bending over. All right, the slant height of a regular pyramid. So we're going to talk a lot about regular pyramids, just so you know. The slant height of a regular pyramid is the distance from the vertex of a regular pyramid to the midpoint of an edge of the base. To the midpoint edge of the base. Or an edge. They're all the same. It doesn't matter which one they go to. Of an edge of the base. Okay? So, lateral area formula for a regular pyramid. So we're going to talk about just regular pyramids. The lateral area L of a regular pyramid is given by the formula below, where P is the perimeter of the base and L is the slant height. So in your book, in your little book, the last one we did was cylinders. Okay, so you got your book open. You have a blue book, and on the left side it says cylinders. We've already done that one. Today we're going to talk about pyramids. Okay? And the lateral area, the L, equals 1/2 P and I put a little cursive L. Since that L is not in our book anywhere, I flip back a page or two, and I get to my key. Okay? And I go down and put that L equals slant height. Okay, so I think the last one we're going to add. Okay? So we'll find the perimeter of the base times the slant height, and then take half of it. Okay? Perimeter of the base times the slant height times the half. Okay? Going over to surface area of a pyramid. The total surface area, S, of a pyramid is given by the formula. L is the lateral surface area and B is the area of the base. So we've seen this one a few times. The surface area equals L. Now we just have one base, one area of the base. Okay? So this L is all of this. Okay? I wouldn't draw that in my book. I didn't, but I'm just telling you. Okay? All right. And last, we're just going to go ahead and write the last one in our book. The volume of a pyramid, V equals, given by 1/3 big B H. So volume equals 1/3 of the area of the base times the height. Okay, 1/3 area of the base times the height. Okay, so that's all we're going to write in our book. Have those in there, and now we're going to look at some problems. We're also going to talk about, just real quick, the altitude of a pyramid, because that's what this H is. Okay? It is the altitude of the pyramid. The altitude of the pyramid is from the perpendicular segment from the vertex to the plane containing the base. Okay? The perpendicular segment from the vertex to the base. Okay? Altitude of a pyramid is from the top, the vertex, straight down perpendicular to the base. Okay? Most of the time, if it's a regular pyramid, it'll hit right in the middle of the pyramid. Okay? They do talk about, recall the volume of a prism is given by V equals BH. The volume of a pyramid is 1/3 the volume of a prism with an equal height and congruent base. Okay? All right, let's work a few problems, and then we'll go on. Okay, if I draw a regular hexagonal pyramid, we're going to pretend, okay, we're all pretending, right? Okay, this is my base. Yeah. A couple different ways to look at it. We're just going to go up. Okay, yeah, horrible pyramid. Okay, but my vertex is up here. My base is down here. It's a regular hexagonal pyramid, so every side is the same. So every one of these is the same. That's a lot of lines on this one page. Okay, and I give you a slant height, an L, that equals 9 inches. It's one of these. Actually, it's from the vertex down here. So it would be a dashed line too, because it's not really there. Okay? Can you find, we're going to go ahead and find all of it. We're going to find the lateral area, the surface area, and the volume. Okay? Can we find all of that just given what we know? Well, let's see if we can. I don't have my calculator handy either. But we'll go with it. Lateral area. What was the formula for lateral area? I'm going to go over here. L equals what? 1/2 PL. Okay? So 1/2, what's the perimeter of the base? Well, every side is 3 inches. And how many sides do we have? 6. So 6 times 3. And then the lateral, the slant height, the L, is 9. Okay? So 6 times 3, pretty sure is 18, right? 18 divided by 1/2, because I don't know what 18 times 9 is. So 18 times 1/2 is 9 times 9 is 81 inches. What? Lateral area is 81 inches squared. Correct. Okay. We've got 1 down. We're staying with the same shape. I'm just going to go right below this. S equals L plus B. Well, guess what? I already have L right there. So I'm going to go ahead and say 81 plus. Now, can we find the area of a regular hexagon for my B? Area of the base. Okay? So I'm going to kind of redraw this. I'm not going to do it. I'm going to do it this way. I'm going to cheat. I'm going to redraw my regular hexagon with side length of 3 inches. Okay? And can we find the area? We're going to pretend this is nice and neat. Of all of these. Do you remember from, oh my goodness, it's probably been at least a week, maybe 2, about our regular hexagons and the apothem. Do you remember that? Can we find, we're just pretending right now, okay? Yeah, we pretend a lot. That every angle through here is, remember, it was 60 degrees. And when we cut it in half, we found a 30, 60, 90. And that this whole triangle was an equilateral triangle. We cut it down the middle, and we made 30, 60, 90 triangles, correct? Yes. So, what is this height right here? They could have given us better numbers, I agree. Okay, so, well, what is the half length? Is 1.5 or 3 halves. My hypotenuse is 3, so 1.5, 3, that's twice. But then what is this height? Yeah, 1.5 times the square root of 3. Okay? Now, if you remember the formula, I rarely do. I'm just going to admit it to you. I rarely do. I have to go back and look it up. But I can find the area of this one triangle and multiply it by 6. I can do that. So the area of one triangle, one whole triangle, is 1/2 base times height. I'm doing fractions and decimals in the same problem. That is so not like me. What's 1.5 is 3 over 2. How about that? Times, it's not the whole height, the square root of 3. That's that 1.5 square root of 3. That's the same thing. Okay? This is one triangle. Equals the area of one triangle. So, if we keep doing this, if we find the area of 1, okay, half of 3 times half of 3 is 9/4. Square root of 3 is the area of one triangle. Well, what's the area of all 6 triangles? Can I do that times 6? Area of 6 triangles, which is the whole hexagon. So 9/4 square root of 3 times 6. 6 times 9 is 54/4. 50. That won't go into that. That's yucky. I'm sure they probably want a decimal, and my calculator is not pulled up right now. I'm pretty sure. Oh, they use different numbers. Oops. That's okay. There's a decimal, 54 fourths times the square root of 3 plus 81. I'm just going to write it all over here. L plus B. I guess I could at least reduce 54 fourths. 54 divided by 2 is 28 halves, right? No, 27 halves. So that's my surface area. Oh, yuck. Sorry about that. And now the volume. How do we find the volume? Yeah, we're going to have to figure out this height straight down perpendicular. Okay? So, could we have a right triangle there with a hypotenuse of 9? Oh, look, do we have this distance here? That's our apothem. Yeah, 1.5, the square root of 3. Can we find the other side? I'm going to have to pull up my calculator, so watch out. Can we find this height? So we would have 1.5 square root of 3. I need to use a different color. Changing colors. 1.5 square root of 3 squared plus x squared equals 9 squared. And my calculator is pulling up now. And it takes it just a second. Okay, I'm going to scoot it over for just a second. X squared equals 9 squared. So what is 1.5 times the square root of 3? 2.59, etc., etc. But then I'm going to take that answer and square it. 6.75, much prettier. Plus x squared equals 81. 81 minus second answer. Okay, so that will be x squared equals 74.25. Okay. Now I need to find the square root of that to give me the height. Square root second answer. There we go. So my height here, the h, 8.6168, etc., 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 probably 6.2. 8.62 is my height. So for my volume, 1/3 the area of the base, which we just found, times the height. So here we go. Volume equals area of the base times the height. So here's my big B. I've got a lot of stuff on my board, and I'm sorry. I'm going to scroll this over where I can still see everything. Look at how nice that works. So 27 divided by 2 times, let's go back up. I think I can. 27 divided by 2 times the square root of 3 is 23. So this number really is 23.38, etc. So I'm doing 1/3 the area of the base times the height. What was my height again? 8.62. So here we go. Times 8.62 equals that divided by 3. It's 1/3. So my volume is approximately 67.2. What units do I have? Inches cubed. Okay. If we want an actual approximation for the surface area, we would take that 23. You've got one of these calculators I love now that you can scroll back up to the answer. Plus 81. My surface area is approximately 104.4 inches squared. Okay? Just getting decimals for them if you don't like the square roots. Because actually they do like several times to give decimals. All right, we found the lateral area, the surface area, and the volume of this one shape. Don't forget hexagons, how we can find those. Okay? And then we're done. That is pretty much it. Our homework today is lesson 70. We're going to do the practice and numbers 1 through 6. Tomorrow we're going to do something a little different. I'm going to try to get a different kind of video, and you're going to predict volume and surface area and lateral area of its shape. Okay, since we just did this. So be sure and keep your book handy, and we'll do that tomorrow on Thursday. All right, we'll talk to you later. Bye.